Throughout its existence, NASA has always been known for its roles in launching space vehicles and conducting missions in space. In addition to these highly visible roles, one of NASA's other responsibilities is the development of new technologies that help make these launches and space missions possible. Although primarily intended for space applications, many of these NASA-developed technologies have also proven very useful in fulfilling needs and solving problems here on Earth. This video provides information about two environmental remediation technologies developed by scientists at NASA's John F. Kennedy Space Center. The first technology, Emulsified Zero-Valent Iron, was developed to help clean up sites where groundwater has been contaminated with dense, non-aqueous phase liquids. The second technology, Activated Metal Treatment System, was developed to remove polychlorinated biphenyls, or PCBs, from aging paint found on or in many structures in the United States. During the 1960s, all eyes were focused above at Cape Canaveral's Launch Complex 34, where a giant Saturn rocket stood prepared to roar aloft. During this astounding accomplishment of landing man on the moon, we here on Earth unknowingly created a long-term environmental impact by dumping chemicals directly into the soil, which adversely affected the ecosystem. With the establishment of the Environmental Protection Agency in 1970, the U.S. government was on course to identify, store, and dispose of harmful chemicals that in turn would lead to the preservation and proliferation of wildlife. Many cleaning solvents were used in the early 60s and 70s by a variety of businesses. These solvents were used by dry cleaners, printing presses, and, in NASA's case, to degrease rocket components. These solvents had wonderful chemical properties for cleaning purposes, but were discovered to be toxic to the environment and human health if inappropriately handled. Even though the EPA has rigorous enforcement in place now, the impact of these wonder solvents still remain today in our soil and waterways, posing a potential risk to our children and wildlife. NASA's Emulsified Zero-Valent Iron, or EZVI, is a new technique for safe and effective cleanup of groundwater contamination. EZVI is an emulsion made from vegetable oil and iron particles that are held together using food-grade surfactant. When injected into the ground where the contamination is found, the emulsion engulfs the contaminant and breaks it down so that it is no longer toxic. EZVI has been implemented at a number of sites, both private and government-owned, with great success. In fact, in 2009, EZVI was used in Europe and in Asia as well. One site where EZVI was deployed was on the EPA's National Priority List for over a decade and has subsequently been taken off the list after the deployment of EZVI. Activated Metal Treatment System, another new NASA technology. AMTS is a thickened solvent paste containing small reactive metal particles that will remove and degrade polychlorinated biphenyls, or PCBs, from a number of different materials in which they have either been placed or with which they have come in contact. PCBs were used on a large scale as early as the 1920s because of their amazing chemical stability, resistance to heat, and a low flammability. PCBs were commonly used in electrical equipment, circuit breakers, hydraulic systems, commercial-grade paint, caulking, and adhesives, and additives in lubricating oils. PCBs have been associated with a variety of health effects on the immune system, reproductive system, nervous system, and are known to cause cancer in animals. AMTS can be sprayed or spread onto PCB-contaminated surfaces or circulated through equipment containing PCB-contaminated fluid to remove the PCBs. The structure or equipment can then either be reused or disposed of using conventional disposal practices. When applied to a surface, the AMTS paste can either be removed so the surface can be reused or left in place if the surface will be undergoing disposal. When circulated through equipment, the remediated fluid would be disposed of using appropriate disposal methods. This results in less PCBs entering the environment.
PCBs are a man-made chemical that were used in the past for a wide variety of applications. They had some great characteristics such as heat and chemical stability, antifungal properties, and use as a flame retardant. These same properties that made them so useful are what make them a problem today. Once they get released into the environment, we have a very difficult time getting them back out. Older buildings were often painted with PCB-containing paints. Current options include removing the paint, which is labor-intensive, or demolishing the whole structure. Both of these options created large amounts of hazardous waste, which are costly to dispose of. A way to treat the PCB problem that would not damage the contaminated structures and not create additional hazardous waste was needed. Activated Metal Treatment System, or AMTS, was developed to provide an environmentally friendly technology capable of destroying PCBs. It's a paste-like system which is applied directly to the PCB-contaminated surface. Over a period of time, AMTS can remove and destroy the PCBs while leaving the structure intact for future use. The application time can be lengthened, or additional applications can be used for highly contaminated sites. The consistency of AMTS allows it to be applied to different surfaces, irregular shapes, or vertical walls. The final result is a clean structure and no PCB waste to be disposed of. The technology behind AMTS is currently being investigated for use in destroying PCBs and sediment systems, which is another big problem currently found in the environment.
NASA isn't just concerned about reaching the stars, but we are also focused on protecting the Earth's environment for our children and all of mankind.